Hey. Hi. So I'll be teaching you guys state management using reducer functions, and I hope everyone uses it in your project, current project. It will simplify your lives. So just yesterday, I saw two senior guys. They were debugging on a project which someone else made, and they were debugging out how did the state change, and they wasted 2 hours on it. I don't want you guys to waste 2 hours on it. I want you to write something better, and you can debug it easily. But I'll be teaching my slides in Swift. That's a catch. And these two programming languages are very similar. They both are multiple paradigm. You can use functions, you can use functional programming concepts, object-oriented concepts, and you can use both Swift and Kotlin in a C fashion, as in procedural fashion. So here we go. About functional programming. What we think of when we do functional programming, as in we have data types, we keep it immutable. We don't change the data types, and we add functions to it. We do the variable dot, as in static constant dot map dot filter and such all, as taught to you by previously Aniket. We have pure functions, as in why do we have pure functions? Why do we prefer using pure functions? Because they keep state management very, as in they keep keeping track of the states very easier. You can track when a variable changed by going through the function. You don't have anything outside of your outside of whatever you are looking at changing the variables without you being notified, or as in you're working through the class and some notification fires and it changes a state. You don't know how did the change state, how did that state change. Am I audible?
Yes.
Okay. Then we try to avoid using side effects, but if we do use side effects like printing the state or then modifying some external global variable, we do it in a controlled fashion, and this helps us maintain our code base testable. So how do we write our regular code? This is what I did a year back. I did mutations everywhere, as in I had a class, and then I had few functions inside the class that changed whatever I needed. Example, here is one of the class. Here are favorite items and integer array, and then I had two functions which changed the value of it. This is how. And I also had side effects, like I printed the state, I then passed the state by notifications, I did so all, and then when it came time for debugging, I didn't know when the state changed. I had to keep track of all of it. So how do we solve this? The mutations, we extract it into something we can think about, or in some another class or another struct or something like that, a data structure. This is what I did. I knew I had finite number of mutations in these two functions, as in not these two, there were many functions and they had the same code repeated, as in append a value or increment the value by 1 or such all. And so that's why I used algebraic data types here and solved it. I'll show you how. So this is where I put in a global variable called appState. Not a global variable, a global class or global struct called appState. And then I put all the things that I wanted to mutate into this, as in a favorite items array here, which is a favorite items array in the class. I put it in the global struct. And then enums or either types, they help you when you have finite number of data points. As in, I had finite number of operations here. There are two operations here. Either added to the list or remove from the list. So I knew these two would be going to happen, so I put it inside an enum. And if there are more possibilities of things that you want to add, as in more mutations you want to add, put those into an enum, as in sealed classes in Kotlin. And then you switch over it. So this is the app state, this is the app action, and then we'll go for a function which takes an app state, which takes an action, and then returns a new app state, as in you have current state of the app. You have a mutation coming around, as in this user liked the image, or user added a favorite number to it. So you do is you have an app state, current state of the app. You have an enum either type that has all the actions of the user, as in the user liked an image. So what you do is you take a function which takes the current state, and then you add to it a mutation, or in whatever the user does, and then you return a new this object, the new state object, and then you save it. That's as simple as that. If you do this, your code will be very testable, very easier to know. All the mutations will be in one place, in one file, and you'll be very happy with your current working code. So there is the reducer function, app reducer function. It takes a current state, it takes a new action, and then returns or emits a new state. And why is it called a reducer? Because when you call functions, as in when you look at higher order functions, there are three types of it. As in the three functions on arrays. You can say one is as a map one that Aniket explained you guys. It takes all the variables in the array, and it takes a function and then applies that function to all the variables in that array. Another is flat map, another is filter, and there's one more called reduce. I'll explain you all these. Map takes a function and applies this function to every value in the array. Filter takes a function which outputs a boolean, as in the list's data type, as in if the list is of an int, it takes a function from int to bool, and then switching on the bool, it filters out whichever returns true. Then there's flat map, which does the same as map and filter, and I'll explain you in later terms. And another is reduce. Reduce takes a function where hold on, it's difficult to explain reduce, but you can define all the previous three functions in terms of reduce as well. So reduce takes a form of an accumulator and a mutation, and then it returns the accumulator, as in the accumulator is the value, and the action it takes, or the mutation it takes, and then it returns the accumulator. So when you have an array of values, and then you do array dot reduce and 0, and then you pass a function of addition. It returns all the values of the array added. Do you want to see how map, filter, and reduce are map, filter, and flat map are defined in terms of reduce, or you want to see any one? I can live code it. So I'm defining a map operator in terms of a reduce operator. So we'll first go ahead with how a reduce function looks like. I take a map operation, which takes a function from int to int, and then I have an array. So this is how a map operation looks in terms of defining it with reduce. Hold on. Am I missing something? Am I missing something? So it's exactly how this should work.
Do you have an example
A result, an empty array. I don't have an example right now. Okay. So what I'm doing is, I take the array and I already have a reduce in it, and then I take an empty array, and this result reduce takes a type of accumulator and the mutation you want, and here I do is the accumulator, I append a mutation to it. Alright, think return result.
It's really hard to do live game.
Okay, no problem. But this is how it actually is defined. Now we have here. So now we have the reducer function, and it takes a current state, it takes a new action, and then it emits a new state. So now you define the reducer. You have a value of type current state, an action, and then you switch on the action. Now I took a copy of a value because I don't want to mutate the value in there, but you can mutate it. So for all the actions, I did is I copy pasted all the functions which mutate, and instead of having those functions which repeat there, I copy pasted it into my app state reducer. Do you want me to go through this step by step? Is everyone? And the syntax is better.
Dollars familiar with the syntax. So
Okay.
just to give
Okay.
us a little dollar.
Sure.
So the dollar or anything sort of. Just like give
Okay.
us a little drum.
Yeah, sure. So all the code that was in the previous functions, I copy pasted it, and if you have more mutations there, you copy paste it here if you want. And this is like for Kotlin you will use it
Okay.
And that's like $0.
For
Java.
For Java.
नहीं है Java, ये Java.
You don't have biota functions in Java.
जो Android में नहीं use कर सकते.
And if you want to print it out, you want to do anything, any mutations. And the switching here in Kotlin, you'll have to use those function names and then function signatures and then equal to and then whatever you want to do. The mutations as in. So this is how after defining this function, now I'll apply it to my current reducer as a current class which is going to use a reduce function. Now here what you'll see is now at the top of it I only have a var state or single variable, whereas in the before slides as in the previous item I had a variable, and if I had more variables I would have had three four variables here, but now all those variables are abstracted away in the app state. In app state here. Now the class takes a state and then it stores it, and whenever a user taps an action, taps it or something like that, something the user does, you call those reducer functions. The reducer functions output a state and then you assign it to your current state. This is one thing you can do. Another thing you can do is you can inline this, you can make the app reducer function directly modify the state variable. So here is I'm using self.state equals app reducer state and the action that the user did. That's as easy as it. Do you want to see a live demo of it? How to do it? Sure. So here we have a class here, and we have a number somewhere, and user is doing some modification on the state. So we have is a user tapped liked on. So I wrote a function. I cooked up a function where a user takes likes on and a value. So what I'll do is I'll add that number to favorites dot append value. It's as simple as that. In your regular code, you'll be doing the same. And if there are more conditions which change states on favorites, you'll write them down in the respective functions. Now, your state looks like. Now you need to abstract out the state. Struct as in sealed class. Which classes? There are sealed classes. There's another is called data class. So data classes and the structs. These two are data types, and they are not. I said in Swift, structs are data types, value types. I'll take this thing. App state. So this is how the first part you'll be achieving a state. Next, you need all the mutations the user can do. So this is one of the mutation. I'll abstract it out away. Enum, mutations, actions, case, user tapped online. It is used by using enum and then a reducer. You take an app state, you take an action, actions, and then you return. So here is one of the implementations. So here is it implemented, and this is how you go from a regular app which mutates states everywhere around to using a reducer.
Excuse me. Why
Yes?
did you write underscore space state?
Okay, so this is Swift syntax. अगर मैं ये निकाल देता हूँ.
Just give me.
Sure. So Swift takes in functions. Swift can take two names. One is for external name and one is for internal name. So external name I'm giving nothing, and internal name I'm giving state.
Is that making it private or something?
No, might be like that. So local scope, and when you access the function from outside, you don't have to pass in a parameter here. See, I didn't pass a parameter here. So you can even modify it. If I remove it, it won't compile. It will take a state here.
Okay.
So where is it getting that state up there in the reducer?
Hold on.
So where is it getting the state in the app reducer when you put the underscore?
Where is it getting a state? So here, when I put underscore, it turns out no parameters for this variable. There are no parameters for this variable. So if I do no parameters as well for this variable, wait, hold on. I need to have some value. So here is how it would look without any parameters.
Okay, can you tell me like what is the difference between a parameter or
So like it's like not a keyword argument.
Huh.
Python.
So then I can have
So in Python you put a slash at the back. What this?
no idea about that.
Fine.
But I can name variables for outside use and name variables for inside use.
Okay, got it.
What thing?
If anyway you don't want to
do I name it? For internal use. Internal use, so that's why I name it.
So you're using it, but still not passing it.
So this is a language construct in Swift, and I don't have to pass in parameters here because external parameters are nothing. These are external parameters, and these are internal parameters. So the function's internal value, internal name reference of the value, and the external reference of the value. It calls
It's like you're initializing a variable for the method, but not a global variable. You would pass it, but you use it in a method. Is that kind of thing?
yes. So this is how it looks. So it will take a state and an action. And if I copy paste this, so this is for another, when I named a parameter, I'll have to pass it, the parameter.
So you're initializing for the method. Is that correct?
So this is how,
Initializing only for your method. And you don't
that's just a method thing.
ऊपर ही करना है. That's the
हाँ.
name.
So this is how these two methods would look, these two functions would look when I pass in parameters. This function takes parameters and this function doesn't take the parameter names. I hope you learned more about, as in how to use traducers in your current app, and don't note no mutations. As in mutations, all the mutations in your app will be at a particular single file or single state, and whenever you want to put in more mutations, you'll put it in there as well, in this enum or then of reducer function, and you'll know all the mutations you'll be doing in your app. So what we did is, this is something called as refactoring, but it will help you out a lot. I already said there were two seniors who wasted 2 hours debugging a code that they didn't write, and that they didn't use reducers, and that they wasted the time and they couldn't debug it as well. Then when you use pure functions, you make it, you can pass a state and then you can observe whatever changes that happen. And this is opinionated, as in you know where a particular mutation will be or where something will be. Now I want to add to it. I want to add to this thing, enum app action. What if I have tens of mutations? Will I write 10 cases here? No, that would be a nightmare for me to manage. I'll do is I'll take a class and I'll put it inside a class, and then I know the hierarchy of it, as in app state dot this screen state dot this mutation, app state dot the screen state dot that mutation, and that all. And the side effects, they are, whenever you want to look for side effects, only this piece of code modifies it, no other piece of code modifies it. That's that's like a win-win condition, and it will help you maintain your code in the future. This slide, I took it from Aniket. Thank you.